Hello everyone and welcome back to the course and actually to the last lesson of this section. Today's lesson is going to be about transformation of functions. Let us start with the concept of vertical shift. Let us consider a function f of x and a positive value a. Then the expression f of x plus a represents a vertical shift where we take the graph of f and we move it a units up. Nevertheless, if we do f of x minus a, this also represents a vertical shift where we take the graph of f of x and we move it a units down. Now it is time to move on to the concept of horizontal shift. Let us consider a function f of x and a positive value a. Then the expression f of x plus a represents a horizontal shift of f where we take the graph of f and we move it a units to the left. And the expression f of x minus a represents a horizontal shift of the function f of x where we take the function f and we move it a units to the right. Now it is time to consider the concept of dilations, starting with the concept of vertical dilation. Let us consider a function f of x and a real value a. Then the expression a times f of x represents a vertical dilation. Now, if a is greater than 1, then the function expands. If a is between 0 and 1, then the function shrinks. Now, if a is less than -1, then this function reflects with respect to the x-axis and it expands. Now, if a is between -1 and 0, then it reflects with respect to the x-axis and it shrinks. Finally, let us study the concept of horizontal dilation. Let us consider a function f of x and a positive real value a. Then the expression f of a times x represents a horizontal dilation by a factor of 1 over a. If a is greater than 1, then the function shrinks itself horizontally. Whereas if a is between 0 and 1, then the function expands itself horizontally. Now it is time for you to apply the knowledge that we learned in this lesson by solving the following problems. You just have to graph the transformations of the functions which are given. And as always, see you in the next lesson.